Good evening, class. Let's start with section 1.1. 1.1 is about data collection. The handout that I'm going to be going through, you can find on Canvas. So let's go ahead and share screen. And this is the handout. It is found under modules, so you could print it or you can write along. But statistics. The lovely blue box is the formal definition of statistics. And you'll come to learn that I really don't like book definitions because anybody can memorize things, but it's the memorizing and putting it into your own words that shows higher understanding. So what is statistics? Well, it's the science of collecting, organizing, summarizing. Yeah. You can read that. But I'm going to tell you something different about statistics, because statistics is about telling a story. It's what it really is. What you're telling a story about is a story of numbers. And statistics is about gathering data and taking that data to tell a story. My example is like, how do you describe a rose? Well, one person may just say it's a red rose. Okay, that's description, right? The next person may say, well, you know, that red rose, it's got a little bit of dew on it and it glints in the morning sunlight, and how it, you can describe how it smells and lots of things. I mean, we all could describe that same rose slightly different. So statistics is about telling a story. I may tell it one way, you may tell it slightly differently. So keep this in mind. You'll hear me come back to this all semester long. What is statistics? We're going to tell a story, and the story is about the numbers. Well, statistics itself is based on two major concepts. The data that we collect, and okay, variation of that data. Because if our data doesn't vary, we really can't run any statistics. So variables, which is our variations, are characteristics within a population. I'm pretty sure we all don't have brown eyes, brown hair, wear glasses. We all differ from each other. Each one of those characteristics is a variable. All right. And the data is the information we collect. If I have 17 students in here, I could go through and say 4 have glasses, 3 are left-handed, 9 are brown-haired. So that's data. It's all the little variables or the characteristics of each person. And of course, variables vary. I kind of already covered that. If our variables didn't differ from each person to each person, our statistics would flatline and we couldn't run our tests that we need to run. They wouldn't work. So variation is key. Now, going back to what is statistics. It's more than just numbers. Remember, I said, what is it? Statistics really is what? Telling a story. But context is key. Now, remember, I've already kind of mentioned it once. I said, you may tell the story one way and I may tell it a slightly different way, but it's how I take the context. Context is key. How are we applying this information? If I just said the number 14, 14 is just a number. But when I add 14 with a label, we're adding context to it. Like I said, how many different students had brown hair? I said 17. 17 students with brown hair. Or I think I said 9. Well, that's giving you a context. If I just said 9, 9 what? 9 what? So without context, we only have numbers. How do we interpret is also a type of context. All right. I'm going to come down here and we're going to reiterate again, because if I keep repeating stuff, guess what must mean it's important to statistics. So our numbers need to vary. And the nice thing is, it naturally happens. Example, cars. Do we all drive the exact same car? I bet we don't. Bet we don't. I drive Kia Sportage. If anybody else out there drives a Kia Sportage, do we drive the same color of car? See, there's characteristic vary naturally. It doesn't take much. And yeah, words tell me I'm being grammatically incorrect there, because I didn't put a period there. All right. So statistics has 4 parts. The definition. And if you look up towards the top, it kind of tells you what is it. Because the first one says collection. We got to collect the data. So in other words, that's your surveys. This is where we go out and we poll people, or we pull things from like government.gov.com or .gov. They've got all sorts of stuff that people already pulled, or the census. That's where you can find all that information. But we go through and we collect the data, whether we go do the pulling ourselves or we pull information from other resources. But we got to collect that data. And then we're going to organize it. Not only do we organize it, we start to summarize it. This is when, what I say, 9 students with brown hair. That's organizing it. That is organizing and summarizing it. I didn't say John has brown hair, Susie has brown hair, Harry has brown hair. No, I said 9 students. That's a summarization. Then once I have it, I'm going to analyze it. What is it telling me? I'm going to go through and look at it. Do I see a trend that all of a sudden redheads are making a comeback? All right. So when we analyze it, we are going to be drawing conclusions about it. And we're going to answer questions that we may have had. So put that under there. Well, if I could type. Because we don't go out and start pulling people unless we have maybe potential questions that we want to answer. Statistics starts with a question. And then lastly, sadly, I hate to tell you this, you're going to find out very quickly there's a lot of writing to do in statistics. I don't run a statistical analysis unless there's a paper that follows. So step 4 is results reported. That's where we draw the big paper up. And part of the reason why we write that paper, we want to convince people that what we found is important. All right. So there's the 4 steps spelled out for you. Now, mathematics versus statistics. Now, with mathematics, mathematics and statistics, even though statistics is a branch of mathematics, there's a difference between math and statistics. Because up until now, when I talk to you about variables, when we talk mathematics or algebra, they're represented by letters. And the main letter we use is the letter X. It's an unknown value. However, in statistics, I told you what a variable was. It's a characteristic. It's a characteristic. That's right. This word spelled wrong. All right, certainty. When we do math, if we're sure that we've done the steps correctly, we know that our answers are correct. We're certain about our answers. Our answers don't vary. Things can equal a specific number. In statistics, we're never certain. Answers vary upon our samples. But I call this our wiggle room. We never state something as a fact in statistics. we'll say something along the lines that we're 95% confident or we're 95% certain. I don't care if it comes out to be 99.9999999, however nice you want to put it, percent. Still not 100%. And we'll never state 100%. It gives us that slight little bit of wiggle room, just in case. Because the minute a statistician says something is for certain, you have other statisticians like me who'll come along to prove you wrong. So we never state 100%. And if anything, we state, hey, next time we always recommend further analysis, further research, and we may even make recommendations on how it needs to research further. But we never say 100%. So watch your phrasing, and you'll hear me talk about this as we progress. We do not say 100%. That is the case, right? So the discussion part, this was an in-portion class. I want you to stop and think right now, because the biggest question I always hear is, why do I need statistics? Well, statistics is actually a valuable class, at least the intro to statistics, unless you're really glutton for punishment. I want to be a statistician like me, because if those who watch the intro video I posted, you'd find that, yes, that is what my degree is in. My degree is actually in Masters of Mathematics, or it's Masters of Science in Mathematics of Statistical Research. I thought they could add a few more words, but they wouldn't. I didn't think the title was long enough on it. But statistics in our everyday life, and people are real good, especially the media, TV, billboards, newspapers. Excuse me. We throw statistics at you quite a bit. So unless you understand, have some basis knowledge of statistics, how do you know when they're lying? Because understand, one of the first questions, remember, that's the reason why I bring this up. My degree is in research statistics. You know what the first question they said we're to ask when we go in to do a research for somebody, like major medical or something? We ask, what is it that you want the research to say? Yes, we know how to make the numbers lie. So I tell students all the time, the idea behind Intro to Statistics is to teach you how we lie. So that when you're in your own careers, you know when to call foul on something. That doesn't sound right. And you can look at it a little closer. All right. So keep that in mind. Now, definitions. What is a population? The population is the entire group. It's seriously that simple. The individual is the singular object of the study. Both populations and something called a sample are made up of individuals, but it's the grouping. The entire population, in other words, if I said all college students, that would be a population. But a sample would be Marian Tech college students. It's a small group of the population. Now, we will want that sample to be as random as possible. So saying nothing but Marian Tech students and then make the leap to all colleges. That's what statistics does. We take a small grouping and we make an inference. You'll hear this here in a moment about the entire population. But we have samples, which is a small group of the population. The population is the entire group. Now, a statistic and a parameter. I'm jumping a little bit. I'm looking right here and right here. A statistic and a parameter basically have the exact same definition. They are both numerical summaries. However, a statistic is a numerical summary of a sample, while a parameter is a numerical summary of a population. I tell students S to S, P to P. Statistic to sample is the same as a parameter to a population. They are both numerical summaries. A descriptive statistic is more about the summaries of tables and graphs. It's a pretty picture as I put it. Inferential statistics is when we take the result of a sample and we apply it to the population. Do you think whenever you hear about the study about smokers that we pulled all of the smokers? The answer is no. We took a sample and then we make the inference about the population. Okay? The biggest thing I want you to take out of this is understanding the difference between a population and a sample, and a statistic versus a parameter. S to S, P to P. A statistic and a parameter are both numerical summaries. However, statistic goes to the sample, parameter goes to the population. Excuse me, I think my nose is starting to try to run a little bit. So at this point, I want you to pause the video and read case A and tell me what you think the parameter is and what the statistic is of the study. In other words, what is the descriptive of the population versus the descriptive or the numerical summary of the sample, all right? Pause it, give it just a few. And you'll find I'm going to continue talking, but when you pause, when you come back, you'll find that I will go ahead and have it explained. This, by the way, is how you truly watch math videos. So, a statistic and a parameter. A lot of times it's easier if you can find one versus the other. So, a nutritionist wants to estimate the mean amount of sodium consumed by children under the age of 10. From a random sample, guess what? They're telling us right there, from a random sample of students under 70, sample 75 children under the age of 10, right there is the statistic, the greenest statistic. So guess what? This first part is the population or parameter. It's all the students, I mean, or all the children under the age 10 in the amount of sodium. Okay. All right, pause it again. Take a chance, read this, see if you picked out the sample versus the population. All right, welcome back. Let's see. An energy official wants to estimate the average oil output per well in the United States. From the random sample of 50 wells for the United States, the official obtains a sample mean of 10.7 barrels. So guess what? Right there, there's the sample. So that means what is the population? The parameter, sorry. The parameter is all of the wells, but more specifically, it's the average output of oil for all wells in the United States. That's the parameter with the population. All right, one more. Pause me. See if you can pick it out. All right. An education official wants to estimate the proportion of adults aged 18 or older who have read at least one book during the previous year. A random sample of 1,006 adults aged 18 or older obtained. 835 of these adults had read at least one book during the previous year. So they're already telling me a random sample. So guess what? Oh man, sorry. I'm getting a tickle. Right there is your statistic. The statistic is that 835 out of 1,006 adults aged 18 or older had read at least one book. That is a statistic. So the second piece, we're looking at what is the proportion of all adults who've read at least one book. All right. Hopefully you didn't find that too difficult. All right. Identify the research object. Well, what is a research object? Well, the research object is like, what do we want? What is the question that we want answered? So a research object is, what am I curious about? All right. And then we collect the data. And then we describe the data. And then we perform an inference. So take a moment and read the example. And then come back to me. All right. Pause it and come back. All right. You should have read it. So let's read it. A high school study has studied sleeping patterns. The association between the start time of school and the sleep duration were investigated. So guess what? Right there is my research objective. Is that we want to study. It's the study of sleeping patterns and association between so I'm cheating here. The association between start time of school and sleep duration for high school students or their sleeping patterns. All right. So collect the information needed to answer the question. Well, the study included 383 randomly selected adolescents from the United States. The sample age was 15.5 years with a standard deviation of 0.6 years. Now you're going to hear about mean and standard deviation quite a bit. So guess what? This part, that is me. It's my study. That's number 2. Collect the information needed. Well, there's the information. All right. So describe the data, organize and summarize the information. Well, that is the sample had a mean. That's what this next whole chunk is. Let's see, do I have it? Nope, just this piece. I get for trying to do this and not read it completely. Let's go green. I like colorful. All right. So describe the data and organize and summarize it. So step 4 is draw conclusions. That's what this whole big chunk is, because it says it was found, those who started, because we're making a conclusion. Furthermore, so if you guys haven't figured it out yet, of all those 4 steps, guess where we do the biggest portion of our writing? It is step 4. The first 3, typically, in any statistical paper, is small. The bulk of the paper actually is going to come from step 4. Is when we start making those inferences and conclusions that we have found. That's us. Step 4, that is us telling the story. All right? That is us telling the story. So yes, the story part is the biggest part of statistics. Now, inference example. The hospital reported that all car crashes pay an average of $9,004 in hospital bills with a margin of error to 95%. So what does that mean? Well, that means, because you need to understand this for it becomes a big portion. It means that we have $9,004 is the middle. And it may be less or subtract off $266, or it could be 9,004 plus $266. It is a range. So a confidence level is a range. So if I add or subtract, that's what it is. I'm adding or subtracting. If I go 9,004 and subtract off, I get 8,738. If I add it, I end up with 9,270. So here's my inference. Percent. Range. My mean is in the middle, but my standard deviation goes down and up. You will learn about this a lot more later on, but this is your first exposure of it. So whenever you hear the word that, hey, we have a mean amount of this, but for standard deviation of this is what we're doing. It's telling you the mean is the middle. We go down by one standard deviation and we go up by another. We add and we subtract. So the hospital bills range from $8,738 to $9,270 per car accident. It's no way I could have said it. All right. But there's an inference example. All right. Let's talk qualitative versus quantitative. Qualitative, again, you guys memorize if you want, but I don't like memorization. I want you to be able to tell me. A qualitative is descriptive. something that can't be measured. So this is based on an attribute or characteristic, okay? The brown hair. Remember I said 9 students with brown hair. That's qualitative. I can count it, but can I measure the color brown? Nope, can't measure the color brown. Quantitative is measurable. So the value, it's like, I love how it says the values of quantitative can be added or subtractive. And I got to watch that a little bit. And here's where statistics bother some students, because guess what? It is a matter of objective or what? Context. Context matters. So if you are talking about, my prime example on this is that age. A lot of times people will tell you age is always quantitative because you can add it and subtract and this and that, right? Well, can I not describe myself as a 21-year-old female? You guys, guess what? I'm not. But when I use it as a description of myself, it can make it qualitative. There's the context. Context is key. All right. So be careful on this. Qualitative versus quantitative. Don't overthink it. And sometimes I will tell students, especially like on something called concept checks, defend your stance. Write me a little why do you feel it's the way it is? Because guess what? I will tell you which is the correct answer. But how can I tell you your opinion is wrong when it's your context? So I know right now people are like banging their heads, and it's like, that's part of statistics. So let's go through this. The colors of automobiles. Already hit that. Can we measure color? The answer is no. So guess what? It is qualitative. The numbers on the jerseys of a baseball team. We think. Do the numbers actually represent anything? Think about that. Do we add and subtract those numbers? Or is it just a way of identifying players? If you're not a sports person, it's how we identify players. You'll hear, like, I'm going to show my age, Johnny Bench wore jersey 5. That was his number. So when you seen 5 out on the field, you knew that was Johnny Bench. It's an identifier, right? However, the number of seats in a movie theater, count those, right? You count them, put them in a row and everything else. That makes it quantitative. All right. How about this one? A list of house numbers on your street. What do you think? Believe it or not, it's qualitative because it's an identifier, location identifier. And I've already given you the last one because I already kind of hit upon it. I'll be honest, because I said what? Age, for the most part, is typically quantitative. All right. So let's talk stacked versus unstacked. And I'm sorry. I hate to tell you this. The first part of statistics, all I'm doing is laying groundwork. Believe it or not, understanding qualitative and quantitative is very important for later on. So right now, this is very boring for you and for me both. However, this is going to tell us later on, and I do mean later on, how do we start our statistics? And it starts with knowing whether something is quantitative or qualitative. So we take time to make sure that you have an understanding. So I'm giving you a data set. All right. This data set is called a stacked format. Do you see how each line represents one person and it's stacked right on top of the other? That is stacked. Now, what does unstacked look like? Well, an unstacked format is we basically take only one variable. Okay? But this is stacked. I don't want to do that. So what does unstacked look like? And I'm going to do this just real quick. And I'm not going to make it. All right. So basically, I'm going to take two items and I'm going to separate it. And guess what? I am going to go through and look at their age. All right. Line 1's a female who is 16. Line 2 is a female who's 20. Line 3 is a male who's 18. Line 4 is a male who's 18. You seen how this is unstacking? It's just shoving everything up. I'm really only looking at specifics. And by the way, we tend to use binary code for things like male, female. It's like true, false, because the top of that category says female. So 1's true, 0's false. So person 1 is a female, person 2 is a female, person 3 is a male because it's false. It says female? No. All right. So that's how we binary code 1, 2. So look over here. First semester, yes. First semester, no. Yes, yes, no. Yes, yes, yes. No, no, no. Catching on. It's just how we code it. But this, back to what it was, say I got 1, 2, 3, 4, 5. So that's 1, 2, 3, 4, 5. Line 6 is a male who is 26. Next line 7 is a female who is 21. I can keep going, but I'm hoping you're getting the gist that the overall is we're comparing ages in male, female. That is unstacked. That's what unstacked looks like. Now, let's answer the questions. How many variables? Well, how many columns are there? See, 1, 2, 3, 4, 5, 6, 7. So there are 7 variables. Now, I will give you a heads up. This is where you'll find very quickly that me and Pearson tend to have a love-hate relationship. Pearson sometimes will tell you there's 6 because it does not count this ID. I will tell you, yes, it is, because when they took the data, I guarantee you there's names there. And the first thing a statistician does is we go through and erase the names and put ID numbers. Because it's getting rid of a bias. We don't want anything that could slightly give us a bias that maybe I hate the name Snuffleupagus. And I have a Snuffleupagus on my list of people. I might inadvertently introduce a bias. I'm like, oh man, it's Snuffleupagus. Every Snuffleupagus I ever met was whatever. So we don't want to see names. We don't. So we take the names out and replace with ID numbers. Well, doesn't that vary? Sometimes when you get ready to do the homework, it'll say that doesn't count. And I'm going to tell you it does. That column does count as a variable. Because for it to be there, that means I took somebody's name or something away from them. Right? And I apologize, my phone just went off. So how many people were surveyed? Well, that's how many lines. 13 people. And we call them subjects, just so you know. We take it more, we immortalize it even more, make it more dehumanized. All right. So now the question is it a numerical or categorical? Guess what? Numerical means quantitative, categorical means qualitative. It is another way of saying qualitative versus quantitative. So looking at this, is this column qualitative or quantitative? What do you think? Even though it's numbers, it's qualitative. We're describing you. Are you a female or not? All right. Now, next question. Is age qualitative or quantitative? Again, guess what? This is just saying the same thing in a different format. Qualitative or quantitative? Well, we can add and subtract ages, right? So it is numerical or quantitative. I'll add that in there just to make it fit. All right. Discrete versus continuous. Now, interest statistics, we do introduce this and we talk a little bit about it, but let me tell you, only those that are moving on does this truly come into play. You need to understand the difference for something called a midterm. So discrete. Both discrete and continuous are quantitative variables. However, think of discrete as stair steps. You have 1, 2, 3, 4. There's no half steps. What happens when you do a half step? You fall flat on your face. So discrete variable is each variable, it has to be in the whole. Think of how many cars you may own. If you have half a car, does it run? Nope, I wouldn't count it as a car. So a discrete variable are considered things that means it has to be do with countable. There's no partials. Where a continuous, I say, kind of flows and ebbs. So that's where your fractionals and decimals come into place. You can spot it kind of quick. Think of height. Is everybody exactly 5 foot, 6 foot, 7 foot? No. I'll tell you right now, I'm 5'3". Yeah, I'm short. But that's partials. Okay? So let's go through this. Pause it for a minute. Go through these. See if you can figure out which ones are discrete, which ones are variable or continuous, and then come back. Now, I'm going to go through 4 cylinders is discrete. You have a partial cylinder, is that engine going to run? No. 188 centimeters tall. In theory, that is continuous because he could continue to grow and shrink. You grow as you get older, as you get to a certain point, and then you start to shrink. It's ebbing and the flowing. Currently, there are 435 House members. Well, that is definitely discrete. I don't know about you, but I'd like to see a half a House member sometimes. Not the end of government. All right, a female student has a circumference of 27.5 centimeters. Guess what? You see that decimal? That makes it continuous. Earthquake has a 0.7. Again, when you see a decimal, it makes it continuous. So continuous is easy to spot. Once you get fractions and decimals, it's continuous. All right. Now, if discrete and continuous wasn't enough to separate your quantitative and qualitative descriptions, we're going to separate it down even further because we have nominal and ordinal. These are qualitative. Both of these are qualitative. Nominals think is like name, labeling, category. Ordinal means it's a ranking. It's a, trying to think of a better way of saying it. Think of ranks of colleges. All right. But it says think order. Now we have interval and ratio. These are both quantitative, taking it a step further. Ratio, it means that there's an ordinal level and heights, lengths, distances, volumes. Big thing is, the value of 0 does not appear in interval, but it does in ratio. Now, this is where I kind of get a little bit, please tell me how you have 0 height or 0 length. 0 distance means you didn't move. But the difference between ratio and interval is whether or not there's a natural 0. All right? That is the biggie. And there's a nice little description of how they rank. Nominal or attributes are only named weakest. In ordinal, we can put the attributes in order. Distance is meaningful. That's an interval. Ratio, we have an absolute 0. So, take a moment. I'm going to tell you right now, the first thing you got to do is decide, is it qualitative or quantitative? And then, is it nominal, ordinal, interval, or ratio? Pause it and see what you come up with. All right, welcome back. This one is nominal. Okay. Hair color is a qualitative account, while they're in order. I know you guys can't tell it, but I've got purple hair. It's dark purple, but I have purple hair. Does hair coloring have a ranking? No. I personally think purple hair is the best, but you know. All right. Numbers on a girl's shirts of a soccer team. Again, we already said that was what? Qualitative, correct? All right. Did the bigger, the smaller number mean anything? No, it does not. So it means there's no order. So it is nominal. Now, ages of students in statistics class. If you told me interval, this would be one that I would say, explain your definition, because officially, as I said officially, it is a ratio. Not exactly one that I agree with. I'll be honest. Again, it's that context and perspective. Because my problem is, can you have an age of 0? Yeah, when you're first born. So please tell me how I have someone in my statistics class with an age of 0 that exists. That's where I said, if you told me ordinal or interval, I'm sorry, if you told me interval, be ready to defend it. And I'd be like, okay, I can see your point. You just heard me how I defended it. Because when I first read this, I put down interval. All right. So temperatures of 22 refrigerators. That is quantitative. So that means, is it what? Ratio interval. Well, can your refrigerator go to 0? The answer is yes. However, the problem is it the real 0? The answer again is no. So it is interval. Look back on page 8, because it tells you body temperatures in degrees of Fahrenheit or something. Well, that'd be the same thing. That's the reason I'm flipping back. What's the page? It is interval. Number of milligrams of tar in 28 cigarettes. Well, officially, that would be what? Quantitative. And can you have 0 tar? Yeah, officially, yes. So it makes it a ratio. Number of pages in your statistics book. If you put down interval, defend it. Because the official answer is ratio. I've yet to see a statistics book that I paid for that had 0 pages. However, 0 can officially exist. All right. All right. What do you think? Marital status. Qualitative, right? Is there a ranking in marital status? Nope. So this makes this nominal. List of 1,247 Social Security numbers. Question is, Social Security numbers, are they quantitative or qualitative? They're identifiers for you, so they're qualitative. Is there an order to those Social Security numbers? The answer is no. All right, movie ratings. We think quantitative or qualitative? Well, when they're saying poor, good, excellent, that's qualitative because it's descriptive. But there is a ranking to that, right? Because good is better than poor. So that means these are ordinal. Final grades, A, B, C, D, F for students in a chemistry class. We think. Don't overthink it. I'm not saying the average or the point grade. I'm just saying A, B, C, D, F. Those are letter grades. And they have a ranking. So they're descriptive of your actual physical percentage grade. Annual salaries for all teachers in Utah. Well, that it would be quantitative. And could you have a zero salary? I would hope not, but it is a potential. So it makes it a ratio. All right. List of zip codes. What do you think? It's qualitative because it's descriptive of where you live, and there is no order to it. There's no ranking. So they are nominal. Nationalities listed in a recent survey. Again, that is nominal. It's descriptive, so it's qualitative. Is there a ranking that one race or nationality is better than the other? I would hope no one said yes. The amount of fat in grams in 44 cookies. Well, yep, that's measurable. That makes it quantitative. And could there be a natural zero? The answer is yes. I'd love to find a cookie with zero fat that tasted decent. There's the key. So it's ratio. And the last one is looking at the chart. What do you think? The data list on the horizontal. Well, it depends which data you're looking on the horizontal, because that's this. I'm going to tell you what they're talking. If you tell me, if you went by the Ford F, Chevy, I would tell you it's qualitative, right? So if you went with that and went by those and it's a qualitative, then you would tell me also nominal. However, the one they're meaning about is the second one. And officially, since this graph has zero on it, the answer is ratio. Because you could have a zero. But if these are the top 5 selling vehicles, why would there be zero? So if you told me interval, because in that line thought, that again, you're saying, I'm telling you, giving you hints, here's how you defend yourself. All right. But this is section 1.1. I'm sorry. I wish I could make this more exciting than what it is. But the beginning of statistics and getting you to understand, actually, you need a firm comprehension of these first few chapters and sections to understand why we do things towards the end. When I mean towards the end, we're talking chapter 7, 8, 9, 10. We're talking the second half of the semester. All this stuff from week 1 is going to come back and smack you later. So start thinking it through, get a grasp, understand what is quantitative versus qualitative, and understand the difference between a statistic and a parameter. They are both numerical summaries, but the statistic is a numerical summary of a sample, while parameter is a statistical summary of a population. That, I promise you, you will see on both midterm and final in some format. All right? Good luck. Let me stop sharing and go back in the recording. I hope I didn't bore you too bad.